Everyone, let's solve some Leetcode today. So today we have Leetcode 347, that is top k frequent elements. In this problem we have been given a nums integer array and an integer k, and now we have to return the k most frequent elements from this nums array, and we can return these elements in any order, which means we don't need to use sorting. Here is a simple example. We have 1, 2 and 3 in the array. The 1 occurs 3 times, the 2 occurs 2 times, and 3 occurs only 1 time. So 1 occurs 3 times, 2 occurs 2 times, and 3 occurs only one single time. Now we have this k integer and it is equal to 2. It means we need to send back or return two most frequent elements, which means we need to return two elements that have the greatest frequency or greatest count in the array. And that is why we are returning 1 and 2, because 1 have the count of 3 and 2 have the count of 2. However, if the k was equal to 3, we would need to return 3 elements that have the most frequency in the array. And right now, it would have been 1, 2 and 3 all. So our answer would have been 1, 2 and 3. This would be the answer. Now there are a few ways to solve this problem. One of the ways is to just sort the array. You sort the array and then you will have something like 1, 1, 1, 2, 2 and 3. Now in the sorted array, you can just take a pointer like p1 and you just store these elements. So you will have a result variable and then we will just store it like this. So first p1 is at this value. So we will store the 1 here, and then p1 will come here and we will check, is this value same as the previous value? If it is same as the previous value, we will simply shift to next one. And here also this one is same as the previous one. So we will simply shift to the next element. So the p1 will be here now. And now we check, is it same as the previous element? No, it is not. So it means we found a new element. So we will simply place it here. And now you can see that the length of the result is basically 2, which is equals to the k. It means we do not need any more elements to store in this result list. So it means we can simply stop this particular loop and just return the result from here. But here is the thing. The sorting takes order of NlogN time complexity, which makes it not very optimized. So is there any other way to solve this particular question? Well, there is. So we have two optimal ways in which we can solve this question. We can use the heaps or we can use the bucket sort. Now bucket sort is a little bit tricky to implement and a little bit tricky to understand, so we are not going to understand it in this video. But if you use bucket sort, you can get up to order of n time complexity and order of n space complexity, but it's a little bit tricky for people to understand. So we will see the bucket sort some other time, but right now the main thing is heaps. This solution is also very optimal and it is very acceptable solution. Suppose we have a list like this. Here we have 1, 2, 3 and all these elements are actually randomized. They are not in sorted order. So how are we going to solve this question with the help of heaps? The first thing we need to do is make sure that we know the occurrence of each element. So 1 is occurring 1, 2 and 3 times. 2 is occurring how many times? 2 times. So we will have something like this. Then 3 is occurring how many times? 3 times. Now what does this thing look like? This thing looks like a hash map. It is actually a hash map. So we are going to create a hash map where we will store the frequency of each element. And now once we have this hash map, we can now try to use priority queue or heaps. So in this case, we are going to use a max heap. So max heap is basically a data structure that will give you the element with the highest priority or maximum priority first. But what is going to be the priority here? The priority is going to be this frequency, because this frequency is what we are using to judge whether we want to actually return 1 or not. And we are only returning the elements with the maximum frequency. So it means we are going to use frequency as the priority. So we will have a heap and we will place all of these elements inside of this heap. Now after placing all of these elements inside of the heap, we will have something like this. And I'm representing heap like a stack only for visualization. Okay, this is just a visual understanding. A heap is actually a tree structure. It is not some stack structure, okay? It's a tree. But just for the sake of simplicity, we are using this kind of visualization here. Now this is a max heap, which means the element with the highest priority is going to be at the top. And that's why we have 1, 3 at the top, because the priority is here 3. Then we have 2, 2. Then we have 3, 2. Now these 2, 2 and 3, 2, actually they are having the same priority. So it is possible that the 3, 2 can be above 2, 2. Or 2, 2 can be below 3, 2. Like that's possible, because heap only cares about the topmost element. This element, the top element, should be of the highest priority. All these elements, well, their order can slightly change each time you run the heapify function to generate a heap. But since their priorities are same, right, x2, it does not matter whether we return 3 or 2 in the list. They are both fine. We can return whatever we want. And here I've made a slight change. The thing is that when we are storing things in the heap, this priority is going to be the first element inside of this tuple. So that's why I'm storing this count or the priority here and this is the number or the element that we are supposed to return. So here 2 is priority and here 2 is the number that we can return. Here 2 is priority and here 3 is basically the element or the number that we can return. So now we can create a result list, and inside of this list we can start adding elements. So the first thing we will do is we will pop the first element from the heap and we will get 3, 1. Now we don't need to check what is the priority, we just need this number, right? So we will take this number and we will place it inside of this result array. Then this thing is gone. This has been popped, right? It is no longer in the heap. Now this thing, the 2, 2 will be popped. Then we will get 2, 2 here like this. And then we will simply take this number 2 and we will place it inside of our result array. And in the same way, we can pop out the 2, 3 also. So we will have priority 2 for the number 3. And then we will just take this number, we will take it and place it inside of the result array. And then we can return it. However, if the k was 2, if we are saying that we only want 2 elements in the result, then this 3 would not be here. But if the k was 3, then this thing would be here. But if the k was 4, what do you think will happen? Well, we will still give the 3 back, and since we don't have any more elements, so the result will only store 1, 2 and 3 in case the k was 4. And that is how, my friends, you can use heaps to solve this particular question. Now let's go through the code. First of all, we are creating this count hash map in which we will store the number and its occurrence. Then here in this for loop, we are actually calculating the occurrence for a given number and storing it inside of the count hash map. Then here we are creating a simple list and calling it a heap. Right now this is not a heap, it's a simple list. Then here we are simply going through our count hash map, taking the number and the count for that number, and then we are appending the negative of c, that is negative of count, and the number here. So this is the tuple that we are appending inside the heap. The reason we are using this negative sign is because in order to create a max heap inside of the Python, you actually have to basically just append the negative sign for the priority. And that is a neat trick to create a max heap inside the Python, because Python does not support max heap, it only supports min heap. Now of course, whenever you are popping the element and you need this priority, you will again have to multiply it by -1 to get the original priority, because in the heap it will be stored as a negative number. Now once we have placed all of the pairs for priority and the number inside of the heap list, we can just heapify our list. So I'm using the heap queue module, and then I'm using the heapify function which is present in the Python built-in libraries, and then simply heapifying this particular list. So this line will simply convert this particular simple list in a heap. So it means this particular heap is simply a max heap now. Now we are creating the result list, and here we are running the while loop. In the while loop, we are running it only while k is greater than 0, so that we will not go out of bounds, and only if the heap contains something inside of it. If heap itself is empty, there is no point in running the while loop. We will simply return this empty list. Now in the while loop, first of all, we are taking the element by popping the element from the heap, and then we are appending the number from this particular element, because the element is going to be a tuple, right? It will have negative c and n, right? So we are going to take the number that is present at the 1 position in the element, and then we will append it into the result array, and then we will simply decrement the k by 1. And once this entire while loop is done, we will have the result inside of the result variable, and then we can simply return it. So now let us try to run this thing and see what happens. So our solution runs in 3 milliseconds and beats 90.44% solutions on Leetcode. It's a pretty efficient solution. Now let us look at the space and time complexity for this particular solution. The time complexity here is k log n. Why? Because we are running the while loop at the end for k times, and each time we are popping the element from the heap, the pop element will take log of n time. And since we are calling the pop function inside of the while loop, it means the pop function for heap will run k times, k multiplied by log of n. And that's why we have this time complexity here. Note that the heapify function that we use to generate the heap from the given list actually take order of n time. So you can also say that this time complexity is order of n if n is very large. Now let us look at the space complexity. And the space complexity is also order of n. The reason is very simple. We have a hash map inside of which we are storing the frequency for each number, right? So this can take order of n time complexity in the worst case scenario, where each number in the given input is actually a unique number. So you will store all these numbers here. And also we have a heap, right? So heap also contains pairs of these same numbers, right? And heap can also be order of n in the worst case, when every element in the given input is actually unique. You will end up storing all of these things inside of the heap. So that is why space complexity is also order of n. Now I know that there is bucket sort also that we can use to solve this particular question, and that will give us order of n time complexity. But that is a little tricky solution, so we will see it later on. So like the video, subscribe the channel. If you have some kind of question that you would like me to target, or you have some kind of topic that you would like me to talk about, just let me know in the comments. Now we will meet in the next video. Till then, bye.